This video corresponds to the first part of Evidence 2, which consists of exploring viruses that are similar to SARS-CoV-2 in both human and other species. Let's move on to the first question. What are the viruses similar to SARS-CoV-2 in the world? First, we need to understand how to determine if two viruses are genetically similar. One of the main criteria used to determine if two viruses are genetically similar is when their genomic sequences have a high percentage of nucleotide or amino acid identity. We could consider that if the percentage of genomic identity is less than 80%, it may be a different viral species, while greater than this percentage would indicate that they belong to the same genus or subgenus, or that they even have close ancestors. Now, SARS-CoV-2 virus belong to the Beta coronavirus genus. This genus is the same as the one responsible for the severe acute respiratory syndrome SARS and Middle East respiratory syndrome MERS. SARS-CoV-2 shares around 79% of its genome with SARS-CoV-1 and around 50% with MERS-CoV. This indicates that MERS is in a different lineage despite being a beta coronavirus. On the other hand, SARS-CoV-1 does share more similarities with the virus we know. These two viruses are the two most similar viruses known to infect humans, although it should be clarified that there are other human coronaviruses that belong to the same viral family and share basic structural characteristics, such as the ones that are right here. However, these have much less genetic similarity, ranging between 25 and 35%. Where we have been able to observe viruses with greater similarities has been in other species, which opens up to the second question: what are the coronaviruses reported in other species that may be close to the SARS-CoV-2 genome? Several animal species have been identified carrying coronaviruses closely related to SARS-CoV-2, particularly in bats and pangolins. Bats, especially those of the genus Rhinolophus, are considered the natural reservoir of SARS-CoV-2 related viruses. Although there are many more viruses contained in bats related to SARS-CoV-2, among the notable ones are the following. The bat coronavirus RAT-G13 shares 95% genomic similarity with SARS-CoV-2, suggesting a recent common ancestor. Tests have even been conducted on the efficacy of current SARS-CoV-2 vaccines applied to this virus with very positive results. We also find the bat coronavirus RMYN02, which shares 93.3 genomic identity with SARS-CoV-2. This variant presents evidence suggesting recombination events within its evolution. Malayan pangolins have been investigated as possible intermediate hosts. For example, pangolin cove is a coronavirus detected in pangolins in China. It possesses approximately 92% similarity with SARS-CoV-2. This indicates that pangolins can harbor coronaviruses from the same lineage as SARS-CoV-2, and this suggests that pangolins might have acted as intermediate hosts during the pandemic, facilitating the adaptation of the virus to humans through genetic recombination with bad coronaviruses. Finally, the last question is reflecting about what should be done during SARS-CoV-2 contingency in low-income communities. I consider that one of the key aspects when managing a contingency in low-income communities is communication. Access to information related to the contingency should be greatly facilitated through available media, which are not necessarily always cell phones or computers. It would be of great importance to have community personnel who can provide clear information about health measurements, relevant information about the current situation, or even to raise awareness about the situation for those who decide not to take this type of emergencies seriously. Of course, medical care should also be available to those who need it, since a low-income community may restrict access to decent medical care. And I believe these 2 points are the most important for managing a situation similar experience during COVID pandemic. And that's it. Thank you.